Hello guys, we're going to do linked list palindrome problem. So we'll be given a linked list and we need to tell if it's a palindrome or not. Um, so there are, so what the way we're going to do it is in O of n time and O of 1 space. And let's get to it. All right. So imagine we have 1, 2, 3, and 2, 1, and also an example 1, 2, 2, 1. So we have odd length and even length, and we want to prove that this one is palindrome and this one is palindrome as well. And we want to also return gracefully when the linked list is not palindrome, right? As in return false. So this should be true, true, false. All right, cool. So our first task is we think that we can get a middle of the linked list and then reverse that linked list and then compare here. So if it's an odd list, then the middle would be at somewhere at 3. So we can do is just take that. So we can reverse this 2 and then compare. So basically 1, 2 will be to 1 and then compare to 1 to 1, which will be correct. And it's here, it'll be 1, 2, and then we'll reverse it. It'll become 2, 1, and it'll match. Okay, so our first task is to get the middle of the linked list, find middle of the linked list. All right, so let's do that. So list node, we need a slow pointer, we need a fast pointer, and while something, don't know what yet, maybe, okay, slow is equal to slow dot next. We'll verify what our condition should be, and this is what we want to do, right? Fast next, because we want the next to move 2 positions ahead than from where it is. So, and here I'm going to say fast, and I want fast to be non-null. And also, I want fast.next to be non-null. Okay, keep that example in front of your mind, 1, 2, 3. And then if you're at 1, and then fast will be at 3, you are at the end of the list, then that means your middle point is 2, because slow is at 2. Okay, so at this point, if you're fast, if it is null, and if it is not null. So let's say if you're at 1, 2, 3, let's take the same example again, and if the slow comes at 2 and the fast is at 2 and 3, now it's an odd length list, and the fast dot next is null. That's why it came out of the loop. And then now the middle is the slow element, right? The slow pointer. So 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 we want to reverse. So fast, if the fast is null in the other case, 1, 2. If here fast and fast dot next and fast dot next, then in that case it'll become null. The fast is null and the slow will be at 2. So in that case, your slow is the start of the next linked list. Okay. All right. So what we found out was here 1, 2, 3. If the fast is not null, then the next linked list that we're going to reverse is the slow dot next. Then so this we're going to change the middle here. If you're going to say middle is equal to slow dot next, and here the middle would be same as slow, because Yeah, that was the opposite. Yep, here. So if I go to 1, 2, 3, then my next is null, and that's why my middle is slow dot next, because I want to reverse this and compare with that. Okay, and here, if you just 1, 2, my fast is going to be null, and then I'm going to reverse whatever that starts from the middle. Sorry, that was a little confusing, but what I'm going to do is now is reverse the linked list. Okay, the second part that we just found. So while middle not equal to null, I'm going to have a linked list node, which will be called reverse. I'll call it ref. It'll be initially be null. And then I'm going to do is let me save the next pointer first. It'll so that I can come back to it. And then I'm going to do this. Middle connect is equal to rev, and keep the middle back to its next pointer. And we want to also change the reverse links back to middle element. So now if you were at 1, 2, then it'll become, so it'll first take 1 and the next element will take 2. So it'll link up like that. So this will be a rev, it'll be a rev reverse, and this will be input element. Okay, so now at this point we have our, we now compare rev and head till we reach da, 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 da. So this one and this one. So okay, so until it's not slow, right? So we have reversed this part, and we should be matching until slow, correct? I hope I have slow saved somewhere. I don't think I changed the slow. Okay. So while something, we want to test if rev dot val not equal to, we want to have some runner here. From start, we're going ahead. So start dot val. We have to return false, because as soon as we know that they're not matching, the reverse string is not matching, it's false. And if it does match, then we want to move forward. Start is equal to start dot next, and rev is equal to rev dot next. So we want to say the rev not equal to null, and start not equal to slow. And if that they come out, then it's always false. Oh, if they come out, then it's true. Because what's happening is, let's take this example, 1, 2, 3, 2, 1. So when it was 1, 2, 3, 2, 1, we found the middle as 3, correct? Because I went to 2, then fast was here, and then slow went to 3, then fast was, null. So at that time, okay, so that was my middle. So now I got my slow. So basically my slow was at 3, and now I'm starting from 1, 2, and I'm going to compare with this guy, with this list, until it reaches the middle. So I think that's correct. Okay. right, that worked. Thank you guys.